one additional measure of center that is of interest for us, and that's what's called finding the weighted mean. So weighted means come up in applications where you have different frequencies or different weights. So for example, if this were the results of a test in a class and you had 5 different grades, 5 students scored a 72, 7 students scored an 81, 2 students scored a 90, 3 students scored a 95, and 1 student scored a 100. Instead of having the raw data where you would list out the 72 5 times, you can put it into one of these frequency tables. Now, with these frequency tables, if you need to calculate the mean, you have to do a little extra work. But keep in mind what's going on here. We have 5 observations of 72. So when you're calculating the weighted mean, you're still going to do the sum divided by the number in the data set. But here, the sum is going to be a little bit different because you're going to have to take 72 times 5. Then you're going to have to add 81 times 7, then 90 times 2, then 95 times 3, and then finally 100 times 1. Because this time, all of my values were repeated multiple times. So you take the value times the frequency, and you'll add all of those up. And then, to calculate the sample size, you need to add the frequencies. So you're going to add the total frequency, which in this case is 5 plus 7 plus 2 plus 3 plus 1. So we do these two calculations. So first I'm going to do the numerator, 72 times 5 plus 81 times 7 plus 90 times 2 plus 95 times 3 plus 100 times 1. And I get 1,492. And then for my total frequency, I add 5 plus 7 plus 2 plus 3 plus 1. That's 18. And so my weighted average, which really is just the average of all of these scores, but it's calculated slightly differently, and I get an 82.9. And if I look at the values here in this table, it seems like an 82.9 would be a reasonable value to be the average. So this is like, I believe, example or exercise 14 that you'll do in this section.